On May 12th, China launched the Xi'an-23 (SY-23) experimental satellite aboard a Long March 4C rocket from Jiuquan. SY-23 successfully entered its planned Sun-synchronous orbit, ideal for space environment monitoring. The satellite was placed in an orbit with an altitude of approximately 598.6 kilometers by 589.8 kilometers and an inclination of 97.8 degrees. This orbit is nearly coplanar with four recently launched Chinese SAR satellites, including L-SAR-1A and L-SAR-1B. Over the next 3 days, from May 12th to May 15th, SY-23 approached L-SAR-1B. Let's observe the relative positions and movements of these satellites. Here, we can observe the radial, cross-track, and in-track ranges between SY-23 and L-SAR-1B on a day scale. This graph highlights the gradual decrease in in-track range as SY-23 closes in. It also shows radial and cross-track were minimal, meaning that SY-23 was launched in a similar orbit plane to its target. Now, let's zoom in on the encounter. This closer view, measured in hours, shows the precise moment of closest approach. As SY-23 nears L-SAR-1B, it executes a corkscrew drift maneuver, spiraling around the target satellite. During this maneuver, the ellipsoids change color from yellow to red as the proximity regions begin to intersect, indicating potential collision risk, but most probably RPO activity between these two friendly assets. Over the span of a few days, the SY-23 satellite demonstrated precise maneuvering capabilities, approaching L-SAR-1B to within 7.8 kilometers. This close approach highlights the satellite's ability to perform complex operations in a crowded orbital environment, potentially for SAR or counter-SAR related tests. Orbit information is provided publicly by spacetrack.org with analysis performed using Systems Toolkit or STK from ANSYS. The space insights were provided by ISR University's Final Frontier Flash newsletter. Thanks for watching.